Okay, so today I want to really quickly go over reducing fractions. You can think of this as the second part to equivalent fractions, because reducing fractions involves finding an equivalent fraction. It just means we're finding the smallest equivalent fraction that we can find. Okay, so again, this is reducing fractions. And the way that we're going to do that is by looking for a common factor. Okay, we're going to look for common factors. And remember that factors are numbers in multiplication equations. Okay, so a factor is a number in a multiplication equation. In this case, because we want to make these fractions into the smallest versions of themselves. The equivalent fraction that is the smallest equivalent fraction for each one of these. So what we want to do is find the greatest, the biggest common factors. Okay? So let's take a quick look at some of these. Some are going to be easier, some are going to be harder. We're going to talk about some ways of working with the harder ones. Okay? And by that I mean problems like this one, where the numbers are a little bit bigger and might look a little bit more intimidating. Okay? So 2/4. Now this one, for a lot of you, this is going to look easy. This is probably the easiest one on this page because 2 is half of 4. Now anytime you have a numerator that is half of your denominator, then your lowest, your smallest, your most reduced equivalent fraction is going to be 1/2. And there's another way to tell that too, because 2 divided by 2 equals 1, 4 divided by 2 equals 2. Now, that brings up another really important point. So I'm using division here because each one of these fractions is a bigger fraction, a fraction with a larger numerator and denominator. So I need to use division to break these down. Now, if you're more comfortable with multiplication, you can do that as well. You could look at a problem like this one, for instance, and you could say to yourself, well, I know what I can multiply to get to 5, or excuse me, what I can multiply to get to 35, right? You could say, well, I know that 5 times 7 is 35. And then you would just look at this one here. You'd say, okay, well, if 5 times 7 is 35, can I multiply anything by 7 to get to 40? Because here's the rule. Whatever you do to your numerator, you have to do to your denominator. It has to be the same. So common factor, look at that word, common factor. That means it has to be a factor that goes into both your numerator and your denominator. So anything that you do to your denominator, you have to do to your numerator. It has to be the same number, okay? So in this case, we know that it can't be 7. 7's not going to work because you can't multiply 7 by anything to get to 40, right? But you can multiply 7 by 5 to get to 35, so why not try 5? Why not try 5? Let's see what happens there. Well, 35 divided by 5 is going to be 7 because we already determined that if you multiply 7 times 5, you're going to get a product of 35, right? In this case, 40 divided by 5 is 8 because 8 times 5 is 40. So then our reduced fraction there is going to be 7/8. Now we know we can't go any lower than that because there is no common factor for 7 and 8. There's no number that you can put into both of those to reduce them any further, right? You can't multiply anything to get 7. Sure, you can multiply something to get 8, right? 2 times 4 equals 8, right? But you can't multiply anything to get 7 other than 1, of course, because the identity property tells us that anything multiplied by 1, any factor multiplied by 1, the product will be that factor. So 7 times 1 is 7, 8 times 1 is 8. That means we've got the lowest. We're the lowest. It's the lowest you can go. 7/8 can't get any smaller. What about 10/16? Well, now you're in another case here. So you might know that 5 times 2 equals 10. But there's nothing that you can multiply by 5 to get to 16. So then in that case, why not try 2? Why not try 2 as your common factor? Well, 10 divided by 2 is 5. 16 divided by 2 is 8. Is there any number that we can put into both 5 and 8 equally? Because we're looking for equal amounts here, right? There isn't. 1's the only one. 5 times 1 is 5. 8 times 1 is 8. So that's it. 5/8. That's the smallest we can go. That's the furthest we can go. So our reduced fraction here course, 10/16 is going to be 5/8. Now, 8/36 is kind of an interesting one, right? Because some of you know right off the top of your heads that 6 times 6 is 36. But 6 times anything, there is nothing that you can multiply by 6 to get to 8. So the common factor can't be 6. Well, think back a little bit. Think back to your multiplication chart. Think back to your multiplication facts and your fact families. 36 divided by 4 equals 9, correct? Because 4 times 9 is 36. So why don't we try 4s? Why don't we try 4 as our common factor? 8 divided by 4 is 2. 36 divided by 4 is 9. 2/9. And there's nothing else we can do there. That is the smallest fraction we could get from that. That is our reduced fraction. And of course, because these are also equivalent fractions, if you had this the other way around, we could have said 2 times 4 equals 8, right? And 9 times 4 equals 36. It works in both directions, right? Now, using an example that I already had down here, 44 over 48, which you can look at in a couple different ways, 44 48ths, talk about it a couple different ways, 44 48ths, or 44 parts out of 48, 44 over 48. Either way, we know that we have a numerator that is 44, a denominator that is 48. Now, these might look intimidating because you might look to yourself and say, I don't remember how you would get products like this. Remember, look at these as products. Look at these as products. Think about multiplication here. Look at those as products. What can you multiply to get 48? What can you multiply to get 44? And is there a common factor? So something that you can put into both of these that would be the same factor, same number, remember, common. Well, if you can't think of something off the top of your head, what you can do is, now I often say, when in doubt, draw it out. Well, with 44 48ths, I'm not going to recommend drawing that out. That would take way too long. You're going to have a pizza with a lot of parts, okay? That better be a big pizza too, because those are going to be some tiny, tiny pieces. So I wouldn't draw it out. So I would say in this case, when in doubt, work it out, okay? What I mean by that is take smaller steps. Let's start with 2's. 2's are usually good ones to start with. Let's go with what we know. 44 divided by 2. Well, 44 divided by 2 really isn't as hard as it looks, right? Because if you looked at 4 divided by 2, you know that that would be 2, and you have it twice. So 22 is 44 divided by 2, okay? Another way to look at it, of course, is that 2's are always doubles. 2's are doubles. When you multiply by 2's, you're getting a double of the number that you multiplied by, right? Or that you're multiplying, right? So in this case, 22 times 2 is going to equal 44. So in this case now, we're looking at 48 divided by 2. Well, 8 divided by 2 is 4, and 4 divided by 2 is 2, because 24 plus 24 is 48, or 24 times 2 is 48. But look at that number though, 22 24ths. That is not small enough. Looking at it, you should automatically know that you can make that smaller. You can reduce that even further. And we know that because we have two nice even numbers right on top of each other, 22 over 24. Well, in this case, I'm going to say, why don't we try 2's again? Let's try 2's again. What happens if I take 22 divided by 2 and 24 divided by 2? Move this down here because I'm running out of space. So 22 divided by 2, again, let's do the same thing. Remember, 2's are doubles. So 2 divided by 2 is going to be 1 and 1. Because also, some of you know your 11s. 11 times 2 is 22. Again, 11s are like using the identity property twice at once, right? Because you've got 1 times 2 and 1 times 2. So you've got 22. 24 divided by 2 is 12. Because 12 plus 12 is 24. Remember that from your 12s. Think back to your multiplication tables. Well, 11 over 12, I can't think of a single factor that we could use there to make either one of those any smaller, because we don't have a common factor. There isn't one single number that we could divide both of those by, the numerator and denominator, to get a smaller fraction. So this is the reduced fraction right here. 11 twelfths. That is our reduced fraction. Of course, again, looking at it, you could do it the opposite way as well. If I had given you 11/12 and I said, find a larger or a greater equivalent fraction, you could have given me 44/48. And that would have worked. Because we're still looking at equivalent fractions. But reducing is a great way to get practice with your division. Okay? But remember, you can always use multiplication as well. Because multiplication and division are related. Because when it comes down to it, math is about relationships. Math is about relationships and patterns. Okay? And you can see that with every single problem on this page here. So if you have a problem like, let's look at one of the ones down the bottom here, 25/60. Let's look at this last one right here. Our numerator is 25, denominator 60. That looks kind of intimidating. It looks kind of intimidating because automatically some of you might look at it and say, oh, well, I know, 6 times 10 is 60. That's easy. 10, 20, 30, 40, 50, 60. Skip counting by tens is easy, right? But 25, that doesn't work. You can't divide 25 by 10 to get anything. It doesn't work. But you can divide 25 by 5, can't you? We know we can do that. And given the fact that we have a 5 and a 0 in the tens place of our number here, that should tell us that we can use 5s here. Because any multiples of 5 either have a 5 or a 0 in the tens place. So that's a pretty big hint that a 5 will work here. Well, you know that 25 divided by 5, 25 divided by 5 is going to be 5. 5 times 5 is 25. You can skip count, right? Well, you can also skip count by 5s up to 60. So if you didn't know this one off the bat and you don't know how to do long division yet, you could do that. You could do it that way. You could say 5, 10, 15, 20, 25. You could even draw it out. Use an array. Make an array. Or grouping. That works too, right? And grouping, if you're going to draw this one out. Now, again, I did say often in cases like this that I don't necessarily recommend drawing them out because 60 is kind of a high one. But you could do it like this. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. How many do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12, which means you know now that 5 times 12 is 60. So now you have 5 12s. So you cannot reduce that any further. And one way you know you can't reduce that any further is because you have a 5, an odd number, over the 12, which is an even number. Now, I'm not saying that sometimes you can't reduce those further. What I am saying, though, in this case is that you cannot. Because there's nothing that you can multiply to get 5 other than 5 times 1. Okay, now, of course, there are things you can multiply, numbers that you can multiply to get 12, like 3 times 4 or 6 times 2, but those do not work as common factors for 5, right? So that means that in this case, this is our reduced fraction, 5 over 12. So, again, when in doubt, work it out. Work it out. If you have to draw dots, if you have to make groups, that works too, okay? But in a lot of these cases, again, drawing pizzas and fraction bars might not work that well. It might work well for a problem like this one, this, but it might not work as well for a problem like this one. That's a lot of drawing. I don't want you to waste your time. Make your lives easier. Look for the patterns. Look for patterns. Look for relationships. Again, in this one, look for what's in that tens place. 5 and 0, that means you're looking at multiples of 5. Automatically, you know that. You're looking at multiples of 5. Can't be tens because it doesn't have 2 zeros, right? But you're looking at multiples of 5, so you can automatically assume that you can divide these by 5. 45 divided by 5 is 9. 5, 50 divided by 5 is 10, because you know how to skip count by tens. So 9 tenths. And again, you know there is no common factor that you can use to reduce 9 tenths any further. So, again, reminder, all these numbers I'm using, these are common factors. These are the greatest common factors. Greatest common factors. Sometimes you might see that written as GCF, greatest common factor. Greatest because we want the biggest number that can go into your numerator and denominator to make those fractions, those two numbers, smaller. We want to reduce. So if we're looking to reduce a fraction, we're looking for the greatest common factor. And again, that is a number that you can use in the denominator and the numerator. It has to be the same number, okay? So every single one of these that we've done on this page, we've used common factors. In this case, we didn't use the greatest common factor. We actually worked it out a couple ways, right? So we did it twice. So we actually used smaller common factors, but we still use common factors. Of course, if you were to add them together, we could have had our greatest common factor right there. These are all common factors, okay? And that is how you reduce fractions. And that is also why reduced fractions are also equivalent fractions. Okay? So when in doubt, work it out, and always, always double check your work. If you have any questions, let me know.